Remember how I said when you think like we've practiced enough, we're going to practice some more? We run out of examples, but I still have more that I want to practice with you because I think that's how we learn it. So let's look at 3.7.50. And remember, this is Chapter 3, Section 7, number 50 out of the exercises. So I just go to the back exercises and pull out. Here's number 50. Okay, so y is equal to sine of x squared plus 1 to the 4th. Now my question to you is, for this one, is the sine squared or is my angle squared? Good, my angle is squared here because it's this inside function. The 2 is next to that. So, but I'm looking and I see a big set of parentheses, so that's telling me chain rule, right? Okay, so let's do it. Derivative of the outside. And I haven't talked a whole lot about it, but you are writing your notation, right? Because notation's a big deal in math. So make sure you're writing that notation. That's going to make a huge impact. 4 times sine x squared plus 1 cubed times the derivative of the inside. But look what happens when we have the derivative of the inside. We've got another chain rule. So when I take the, now this is a 0, we know. But when I do this one, I've got an outside function of sine and an inside function of x squared. So the derivative of the outside, keeping the guts, times the derivative of the inside. Are you seeing this? Yeah, it's really just getting used to identifying the outside and an inside function. All right, then just clean it up. Y prime is equal to, it's multiply, so 4 times 2x will give me that 8x. I'm going to go ahead and bring this cosine x squared in front. And then I've got sine x squared plus 1 cubed. It's just good practice. Anything that's singular like that, you just bring it in front of your parentheses. All right. Okay. Let's do more. Let's do more. I told you we were going to practice some more. We got this. 3.7.32. We're going to find the derivative of y is equal to cosecant square roots of x. You know I love trig, so we're going to keep on doing it. Okay. What do you see right now? Yes, we see trig. Good. And a radical. Good job, guys. So y is equal to the cosecant here of x to the 1/2 power, right? And that is my inside function because it's just to that variable. All right. So the derivative of cosecant, notice I just changed with the algebra, so I kept my y. Got a derivative here. Yep, cosecant, cotangent. Now, when you do cosecant, cotangent, and negative, of course, cosecant of x to the 1/2, cotangent of x to the 1/2, this inside function, when you do cosecant, cotangent, goes to both. Yes, now I'm multiplying by the derivative of the inside. And my inside function here is this x to the 1/2. That is an inside function, even though it's written twice, and it's only written twice because of the derivative of cosecant. My actual inside function here is this x to the 1/2. Do you see that? So that's my actual inside function. So bring the 1/2 in front, subtract 1 from that exponent. Yeah. Okay, then clean it up. Oops, go back to black. I've got a negative 1/2 x to the negative 1/2 power, cosecant x to the 1/2, cotangent x to the 1/2. And honestly, I'm going to change these to the square root of x because I think it's easier to look at. Square root of x, square root of x. I feel like it breaks it up more. All right. Very cool. Very, very cool. Okay, let's do more. Do I have room? Oh, yeah, we do. We just started this page. We got tons of room. 3.7.58. We get y is equal to x minus 1 over x plus 1 to the 8th. Oh, what do you think we get to do? Yes, we get to do the chain rule and the quotient rule. Oh, this is so exciting. Okay, let's do it. Y prime is equal to 8. Keep those goods. So bring the exponent in front, subtract 1. And then when I take the derivative of the inside, you get a quotient. Yes, you guys are so good. Derivative of the top, that's easy, right? Is a 1 times the bottom minus the top times the derivative of the bottom. Wow, that's easy again. All over the bottom squared. All right? Okay. Now, you need to clean this up. Your final answer, let's make a note of this. Your final answer should be a single rational expression, which means quit being lazy, put this together. That's what that means. And so not so many terms. Remember what we said earlier? With your rational expression, your exponent goes to both parts. So we can rewrite this as y prime is equal to 8 times x minus 1 to the 7th over x plus 1 to the 7th times, we don't need that dot there, we've got grouping symbols. Here, don't forget this is subtraction, so you have to switch both of those, which means plus x and minus x cancels, and I have a 1 plus 1. Oops. So that's going to be 2 over x plus 1 squared. All right? Okay. Now just combine it. Y prime is equal to 16 x minus 1 to the 7th over x plus 1. Remember, like bases, add those exponents. Not too bad, right? No, it's not too bad at all. Oh, I'm out of room on this. I got one more for you. One more, and then we'll call it. 3.7.63. I have y is equal to parentheses of x plus 2 and x squared plus 1 to the 4th. Now, we're amazing. We know this, right? You guys are so awesome. So if we're looking at this, be strategic with how you do this. These are two binomials. Don't go trying to make your life harder than what it has to be. Multiply those things together first. Algebra this first. Anytime you can algebra first, do it. Let me send you back one. Over here, there's nothing I can do to that. There's nothing I can do to that. It just is what it is. If you're stuck with what you have, that's totally legit. Then we have rules to accommodate that. But if you can make your life easier by doing a little bit of algebra, do that. Do that for sure. I haven't taken derivative yet, so I still have my y equals, right? Okay. So I have, when I FOIL this out, x cubed, right? First, outer, inner, last. X cubed plus x plus a 2x squared plus 2 to the 4th power. And that is easy, right? Yeah. So y prime, first time I'm taking a derivative, I still have an outside function here. Bring the 4 in front. When I keep these guts, I'm going to go ahead and rewrite these so that I can have it in descending order. So plus 2x squared plus x plus 2 cubed, because remember it's derivative, times the derivative of the inside, 3x squared plus 4x plus 1. And then just clean it up a little bit. Honestly, you could leave it just like that. It doesn't hurt a thing. There's nothing else I can multiply. I've just got those sets of parentheses. And it's no big deal to have that set of parentheses in the back. So frankly, I'd probably just leave it. Okay? Cool. The big deal on this, identify those outsides and inside functions. Right? Identify the outside and the inside function. And work that through. You guys got this. I'm confident.